Guys, guys, wake up. We have to. Guys, guys. Sean. We're recording now.
Yes. Welcome to the Moon and Back. We're back this week with another exciting day with some new information and a new set of puzzles for you to solve with your homework that we will get into later. Now, today we are not just traveling to the moon and back, but we are traveling to some very important planets and back that they themselves have some pretty incredible moons that we're going to talk about. Before we get too deep, my name is Will, and if you don't know me, my name is still Will. And my friend over here, this is...
My name is Sean, and if you don't know me, my name is also Sean.
Exactly. It stays the same whether you know us or not. Now, we are going to talk about gas giants. Last week, we talked about the terrestrial planets, so those are the ones with a nice hard surface, very much like Earth. If Earth was a gas giant, we would just have nothing to walk on. We would just be fish, I guess, floating through a bunch of gas. However, we are going to be talking about the biggest gas giant in our solar system first. This is Jupiter. It gets its name all the way back to Roman times. And that is what they basically considered their god. You've heard of Zeus. The Romans, they had the same guy. They just called him Jupiter instead. And basically, why that? Because it's the biggest! It's the king of the planets. All right, now we've got Jupiter. It has an orbit of 398 days, all right, going around the sun. So that is pretty close to Earth. Pretty close to Earth. A little bit longer, but not by much.
It also means it's going really, really fast because it's distance from the sun's. So if you guys remember, an AU is an astronomical unit, which means the distance between the sun and the Earth. And Jupiter, at its closest, is 4.95 AUs from the sun, and as far as it's 5.2 AUs. So that means Jupiter is going really fast compared to the Earth in its orbit.
Exactly, so it's traveling very, very fast, which makes sense if he's the king of the planets. All right, now, here's another very, very fun, interesting fact. It has 79 satellites. Now, remember, what is a satellite again? A satellite isn't something that we necessarily put up. It is essentially any natural body. So you have the difference. You have natural satellites and you have artificial satellites. So when we launch our own stuff up and it circles around, that would be an artificial satellite. A natural satellite would be very much like that bright, shiny cookie in the sky, the moon, which means that Jupiter has 79 natural satellites or moons. All right, it's very, very, very cool. Its mass, on the other hand, wow, it is 317.8 Earths. That means you would have to multiply Earth by 317 to even get close to the size of Jupiter. That's very, very, very big. And it is also, in comparison to the sun, still very, very small, which gives you an idea of how big the sun is. Basically, you can fit 1,047 Jupiters in the sun. That is crazy. The sun is absolutely just explosively big.
Another way that you guys can think of how huge the sun is, the sun has 99% of the entire mass of the solar system in it.
Wow.
So the sun is massive.
Excellent. Now, we're going to get into gravity. Now, gravity is calculated essentially on Earth. We have one gravity. Now, on Jupiter, it is much bigger, and it has more mass, which means there is more stuff pulling you into Jupiter, which means its gravity is going to be greater. So it is 2.52 gravity units. So if you went there, you would be not only twice as heavy, you would be a little bit more. You'd almost be 3 times the weight. So if you weighed 100 pounds here on Earth, in Jupiter, you would weigh 250 pounds. All right, its atmosphere is 89% hydrogen and 10% helium. I'm sure there's some other stuff in there, but from what we have gathered with our different satellites that have gone there and probed and explored it, it has a lot of hydrogen and some helium. All right, now its temperatures, I'm looking at right here, is negative. So it's kind of a cold place to be. It has negative 226 Fahrenheit, and then at nighttime it's going to be negative 320 Fahrenheit.
Although there is a lot of atmosphere, guys, remember it's really far away from the sun, so not that much light gets to it to heat it up. So one of the craziest things about Jupiter's atmosphere is, in pictures, you guys have probably seen it, it's its giant red spot. Now that giant red spot, we've been able to see it since 1655. And what that giant red spot is that it is an anticyclonic storm that's bigger than Earth. As a matter of fact, we think it's about the size of 3 Earths in size, and it's one giant storm that's been raging for close to over, that we know of, 400 years. Now, the weirdest thing about this giant storm is right now it's actually getting smaller, but it's been visible from Earth through telescopes. And that is the only other, we'll call it weather, that we've seen from Earth besides Earth with telescopes.
Excellent. All right, now we're going to go ahead and change topics from Jupiter just a little bit. We're going to talk about some of its very important moons, 4 of its specific satellites that we call the Galilean moons. And they're called that because there was a guy named Galileo, and he was the one who first discovered the 4 first moons on Jupiter. And he discovered them all the way back in 1609, and these were the first objects that us humans have ever seen orbiting a planet other than just the moon. So we had seen the moon, it goes around the Earth, we've seen other planets, what have you, but he noticed that there are actually some objects orbiting another planet, orbiting Jupiter specifically. And we named them. We have Io, Europa, Ganymede, and Callisto. NASA recently confirmed that Europa has water vapor. That's really awesome that it has water vapor on there. And that's why we're actually very interested in Europa specifically, because a lot of people think maybe because it has water vapor, that possibly there might be some kind of life, microbial life or what have you, or that it might be possible to send humans there in the near future and they'll be able to drink the water vapor, and so you'll be able to live there or terraform it in some kind of way. So we're really interested in Europa, and so that's really cool.
So Galileo was actually a really important dude in science. He was alive from 1564 to 1642, and because he noticed those other moons floating around Jupiter, he had an idea. What if the sun was at the center of our universe and the Earth wasn't? So way back in the day, guys, ancient people and ancient astronomers thought that the Earth was in the center of the universe. But Galileo proposed that actually the sun was in the center of the universe. And that fixed a lot of problems that people had with observing the planets in the sky. Because on Earth, the planets look like they go back and forth in the night sky through their orbital period. However, we know that in space they make circles. Well, if you're on Earth, that means that you're not in the center of the universe because not everything is rotating around you. And that is called heliocentrism, helio being the sun and centrism being at the center of the universe. Mm-hmm. What's also really cool about Galileo is he was one of the first pioneers of telescopes, and it was through his inventions, basically, his ability to take the telescope and make it all the way up to 30 times magnification, which is a lot for his time because he didn't have all the tools needed to get bigger. He was able to see stuff like the moons of Jupiter and even some stuff on Saturn that we'll get back to in a little bit. Also, I think probably the most cool thing about him is that he was called the father of modern science by Albert Einstein.
Excellent. Now, another point when Sean was talking to us about the planets, how on Earth, when we observed the planets, unlike all the rest of the objects, so the stars, they all go in one direction and then keep going in one direction year after year after year after year after year. And that's why we can plot our navigation by sea by the stars, because we know where they're going to be from one month to the other. However, the planets, like Sean was talking about, would go one way, and then the very next month, they'd look like they were going the other way. So we called them planets. We didn't call them stars, even though they look very much like stars. We called them planets, which means, in ancient Greek, it means wanderer. So they were, I guess, to them, stars that wandered. They didn't go the normal path. They kind of, to their mind in the ancient world, had a mind of their own. And so they could go one way and then back the other way. And that's why most of the planets are named with the gods at the time. So like Jupiter was called Jupiter, and that was the Roman god. So that is just a little bit more facts. Planet means wanderer. And we're going to go ahead and move on to the next topic, which is still Jupiter, but it is a specific probe that we launched. So it's a spacecraft that has no humans on board that we sent to Jupiter to explore it. And we sent it to explore it back in 2011, and it didn't arrive until 2016. It's called Juno. It cost $1.1 billion. And some of the very cool, important things it discovered is it discovered more storms on Jupiter, and it discovered that basically this planet, so far away, so big, has weather very similar to Earth. Storms. All right? Another thing, it also saw volcanic plumes on one of the Galilean moons called Io. All right? And it also discovered that it had a magnetic field, which we figured it had, but that its magnetic field is a little bit strange. We have a north magnetic field in Jupiter and a southern magnetic field, but one of these pieces on the top of it moves around kind of all crazy like, and then there's a southern one, but I wouldn't really call it a southern one, that's actually not in the south, but it's actually at the equator. And so that causes, they think, a lot of these different storms to be very erratic. And they think one of the reasons that is causing this magnetic sphere to be strange is that it has a hydrogen core, and that it's in there and it has been compressed and compressed and crushed so densely that it actually has formed a liquid metallic-like substance. And that's why they think that we have this magnetic sphere that's acting all crazy and strange out there. Now, we have a quick little video that is talking about Juno. And we're turning off the words because we wanted to talk about some of the things that it's going to have come on up here. Now, right now, it's just showing a little bit of a blueprint on it. This is a recreation of what Juno was seeing, but a good idea of what Juno itself looks like. As you can see, this is a probe. Now, your homework is going to be creating a probe, very much like last week, but it's going to be exploring one of the gas giants. And we can see this line right here as Juno goes out. It's launching from Earth, it's making a big, big, big orbit around the sun, but on its very first pass, it's not actually making it all the way to Jupiter. That's why it took so long to get there. And you'll notice everything goes in circles. Everything is traveling around the sun. It makes a flyby of Earth, and now it's making its big jump all the way out to Jupiter on its big, big, big push, which means back on that other side when it flew by Earth, it had to use its engines to go ahead and get it to push even farther. Now, like I said, it started in 2011 and got there on 2016. And here are some actual images of it in space.
Now, why was that doing 2 orbits was so important? Why couldn't it just go there on the first one? And that's because it didn't have enough speed from just taking 1 orbit, so it had to get really close back to Earth and use that speed of Earth's gravity to help push it all the way through. Now, there are a lot of hypotheses on why the gas giants and Jupiter in particular are so important. And one of the most popular theories right now is that you need a Jupiter-sized gas giant in your solar system so that way planets like Earth can exist without getting hit by asteroids. Jupiter's and Jupiter-sized gas giants end up absorbing and changing the orbits of a lot of smaller objects coming into our
Solar system.
So they go to Jupiter and then they won't hit Earth.
Yay! So he's kind of like a big protective shield.
Yeah, he's like a giant shield.
Yay! All right. Let's go ahead and move right on to, I think, another very fascinating planet in our solar system.
And my favorite planet.
Ooh, favorite. I can only guess why. This is, once again, another gas giant. This one is Saturn! Woohoo! Yeah! It has an orbit. Wow, is this orbit crazy long? It is an orbit, not in days, but an orbit of years. Now remember, it's very far away. It is 29.45 years away, which means I wouldn't even be 1 year old over there. I'd be like 1. That's about it. Yeah, I'd be about 1 year old, maybe a little bit more, I think. All right, its distance from the sun is 9.04 AU. At its closest, at its farthest away, it is 9.58 AUs. That's astronomical unit. That is the distance from the Earth to the sun, and we just add those up to see how far away it is. Otherwise, if we measured it in feet, it would take us forever. That'd be a big number. All right, satellites! It has, of course, some of its own natural satellites. We're not talking about artificial ones. We're talking about natural satellites. So those are moons, but we call them satellites. So that is 82 of them. That's quite a lot, quite a lot. Its mass is 95.15 Earths, so it is very big. It has lots and lots of material on there. Its gravity, though, is 1.06. So its gravity is very, very close to Earth's gravity, actually, just a little bit more. Now, its atmosphere is 96.3% hydrogen and 3.25% helium. So it has more hydrogen than Jupiter does and a little bit less helium. But they're comprised of mainly the 2 same gases, hydrogen and helium. All right, its temperature, once again, is going to be very cold because it's far away from the sun. It is going to be negative 282 degrees Fahrenheit, and during nighttime it's going to be 372 degrees Fahrenheit. Now, Saturn's rings are a really, really fun thing to talk about because they're really awesome. And I'm sure, Sean, that's the reason why you like Jupiter.
You mean Saturn?
Yep, that's why you like Saturn.
Yeah, so the rings were first seen by Galileo in 1610. However, he didn't actually think they were rings because his telescope that he was using wasn't strong enough. So it wasn't until Christian Huygens in 1659 had a strong enough satellite to actually be able to see that there are rings around Saturn. Galileo just thought that there were some weird moons around Saturn, not this giant set of rings. Now, the really cool thing about these rings is they are made up almost entirely of water and ice with a little bit of rock materials thrown in there. So it's one of those weird, unique space things that we still don't know how they were formed. Now, its size ranges, so what we mean by this is the distance that the ring starts to how far it goes out into space is from 4,120 miles to 75,000 miles. So this is a really, really wide set of rings. However, they're actually quite thin. They're only about 20 meters. So in us American terms, that would be about 20 yards or about 2 first downs in a football game.
Exactly.
Because that's the best way to do science, is in football games.
Yes, exactly. So basically in space, the distance of how thin they are is pretty much paper thin when you're comparing all of these other things in the solar system. I think we got everything on Saturn?
Except for one last thing with those rings is that they are actually kept in place by the satellites, the natural satellites, those moons of Jupiter. Sorry, the moons of Saturn.
We keep changing it. The moons of Saturn!
Now, Saturn was really, really cool, and the space agency NASA also agrees. So we sent a space probe there, and it started its orbit in July of 2004. This was the Cassini-Huygens space probe. Now, this probe had 2 main objectives, and one of the objectives was really, really cool. Once it got into orbit, it was going to send a probe from the satellite to one of the moons, and that moon was Titan. Now, the reason we wanted to look at Titan is because we thought that Titan was solid, and that maybe there was something on there that we could use if we ever went there with the spacecraft. And so they sent a probe to Titan, and that probe was very small, and it was built so that way it would just land, even if it had to crash land, and it only had about 3 hours worth of power for it because it was powered by a battery. And what they thought is that once it crash landed, we would be able to get about 30 minutes of information from it. And what it sent back was really amazing. It sent back pictures of the surface of Titan, and what it found on there was ice crystals that were between 20 and 25 centimeters in size. So we found water ice on the planet, on the moon as well, which is a really cool find because that means there's more water in our solar system than just on Earth.
Ooh, very interesting. Now, we have covered 2 of the gas giants. Now, you may be thinking, there's more gas giants! Well, there is. And we're going to be talking about that next week. And we're going to be telling you why next week, why we decided just to talk about these 2, and the other ones, we're separating them. Because they're not anymore specifically just gas giants. Now, as far as your project or your mission for this week, it's very much similar. However, the probe that you're going to be launching is going to go to either Jupiter or Saturn. And it's going to probably not be able to land because these are gas giants. So you have to tell me, what are you trying to explore? Are you going to Jupiter to explore the red giant, or the red ring, or the red dot, the red spot, the storms? Are you going there to explore the magnetic field? Or are you going to Jupiter to explore one of the moons, and which one? And so you need to design your probe to accomplish the mission that you set out. And so that's the general idea. You'll have to tell me how you're going to accomplish that. And you need to design it the same way you did last time with different things. You need something for power. So how are you going to get power way out there in Jupiter? Yes, the sun, so solar panels are a good idea with batteries. But what happens if you're on the other side of Jupiter and there's no sun? What are you going to use instead? You're going to have to do your own research to figure out what we could do to get out there. There's lots of different things, and if I tell you all the answers, you won't do the research yourself. So I'm going to leave it out there kind of vague. So solar panels, sure, that's great, but how else could you get power? Way, way, way out there. All right. Another thing, if you're going to be exploring Jupiter or Saturn, you're going to have to indicate to us 3 hazards. 3 hazards that will be damaging or potentially damaging your spacecraft while it's trying to get data. So what are those 3 things? So you're going to have to do your research on what those 3 things might be and come up with a design that will protect it from that. So there's lots of radiation on both of these planets. So what are you going to do to make it so you're safe from radiation? If you're going to be exploring deep into the atmosphere of Jupiter, what are you going to do so that you don't burn up as you go in there? Again, if you're going to be going to one of the satellites, that's totally okay. Maybe your mission is to go circle to Jupiter and then send something to Europa. That's cool as well, as long as you're indicating what the hazards might be. And once again, you're going to want 3 different things that how are you going to get your data? So are we going to be taking pictures? That's one way to get your data. What other ways can you get data from a gas giant other than just pictures? So that is it. Draw a beautiful picture of your spacecraft. Color is great, and make it nice and beautiful, and you're going to need to give it a name. So go ahead and name your spacecraft, send it to us, and I can't wait to see them all, because last week all of them were super spectacular. I really liked the one that the wheels themselves had scoops in them so that they could collect soil samples. So instead of having an arm that goes out and collects the soil samples that would be taking up extra energy, the wheels themselves basically had scoops to get all that material. So what a fabulous idea to conserve energy and get the data that you need. So that was awesome. All right, I can't wait to see all of your other wonderfully beautiful ideas. And until next week, goodbye!